All right, what do we got here? We have an angle, one angle. We have its opposite side. And we have another side of a triangle, which will be an adjacent side to my angle. So I have two sides of a triangle and an angle that's not between them. This would be the ever dastardly side-side angle configuration. This is the ambiguous case for the law of sine. So first order of business is to figure out, do we have one triangle, do we have two, or do we have none at all? A picture is a really good idea in a case like this. So I'm going to draw my little 12-degree angle here. There we go, 12 degrees, angle C. And my adjacent side, A, is 7. And then my opposite side has length 3. Does it fit at all? One thing I can tell for sure is that my opposite side is not longer than my adjacent side. It's shorter, so I don't have one triangle. I might have, well, I guess I could have one triangle if I have a right angle. But I might have two, or I might not have one at all. How do we tell? We find the height. So the height of my triangle is here, straight down, so that I get a right angle. There's the height. The sine of my 12-degree angle is the height divided by 7. So if I solve for h, there's my height, 7 times the sine of 12 degrees. If I do that, I get 1.46. Now I got to compare. Well, my opposite side C is longer than the height. And at the same time, we already observed my opposite side C is less than the adjacent side. When both of those things are true at the same time, this is the two triangle case. What that means is my opposite side of length 3 will fit two different ways. It might be this way, or it will fit this way, and it will fit going the opposite direction as well. So I'm going to end up with two different versions of angle A, two corresponding different versions of angle B at the top, and two corresponding different versions of side B at the bottom, and we want to find all of those. All right, one thing at a time. Let's look at this case first when I'm swinging out away from my angle. Down here I have, we're going to call that angle A1, which makes this one B1. And its opposite side, little b1. And we're going to do this just the same as we always have. First thing I need to do is find angle A, just because of the information I have. I have side C and angle C is my matched pair, so I can set up the law of sines with those. Sine of angle C divided by side C is the sine of first version of angle A divided by its opposite side. Multiply everybody by 7. That's the sine of angle A. I don't want the sine of angle A, or A1. I want actual angle A1, so I'm going to use the inverse sine of that. And we get a measure for angle A1 of 29.02 degrees. Now I have two angles in my triangle, so I can find the third one by subtraction. B1 is 180 minus C minus A1 We get the first version of angle B, 138.98 degrees. One more thing to do, and that is we want to find side B1 down here. I'll use my sine of C over C again, and that'll be sine of B, and I'm writing 138.98 degrees, but I'm using all of the decimal places that were calculated for angle B, and I'm going to round off only at the end. And side B1 is what we don't know. So we're going to multiply by 3, multiply by B, and then divide. By the sine of 12 degrees. And we get a length of the first version of side B of 9.47. That does make sense here since angle B1 is the biggest angle in this triangle, that side B1 should be the longest side, and it's longer than the other two at 7 and 3. And we're halfway done. We have another version of this triangle with another version of angle A, another version of angle B, and another version of side B. The way we make the transition from the one triangle to the other is like this. The second version of angle A, that was the first thing we found when we only knew one angle and two sides. The second version of this angle is 180 degrees minus the first version of this angle. And this is the key to getting from the first triangle into the second triangle. So we just found A1 a minute ago. It was 29.02 degrees. So my second version of angle A here has a measure of 150.98 degrees. That makes sense with the picture. My angle A2 is obtuse. This is obtuse. Seems reasonable. To find the second version of angle B, we'll do that like we always do when we know two angles of a triangle and we want the third. We'll do that one by subtraction. 180 minus the two angles that we know. And for angle B, we get 17.02 degrees, little tiny angle B up there. The last thing left to do is find the remaining side, which we can do with the law of sines. So that's the sine of B2, which we just found, so I don't really have to call it B2. I can call it what it is, 17.02 over, I don't know, equals, and we'll use the given information, sine of 12 degrees over 3, multiply by 3, multiply by B2, then divide, and we'll get the length of side B2 is like that. And when all the dust has settled, we get a length of 4.22. And we have now found all the information about both triangles.